All right, let's dive right in. Welcome to today's explainer. If you're an AI product manager trying to build smart applications right now, you've probably been drowning in a sea of jargon, right? We're talking embeddings, cosine similarity, vector dimensions, the whole shebang. Well, today we're going completely hands-on. We're going to translate all that complex vector math into actual, actionable product strategy. We're breaking down vector databases, what they are, why they're literally the backbone of modern AI, and exactly how you can leverage them to build much better, more reliable products. Here's the roadmap for our explainer. We'll start with the unstructured data problem, move into the core concepts of vector space, and then break down the RAG workflow. After that, we'll look at KPIs and product strategy, and wrap up with common pitfalls to avoid. Basically, we're going straight from the core problem all the way to execution. Okay, I want you to anchor everything we talk about today to this single, crucial idea. Vector databases are the infrastructure of memory for AI. Think about it. In this era of generative AI, large language models are incredibly smart, right? But they have a massive, fatal flaw: amnesia. They only know what they were trained on months or sometimes even years ago. Vector databases act as their searchable, long-term memory. They let your LLMs access massive, private, and real-time datasets without you having to spend millions of dollars retraining the core model itself. So let's kick things off with Section 1, the unstructured data problem. Let's see exactly why traditional databases are just falling short for modern AI. Now, this gets right to the core pain point every AI PM faces. Traditional SQL databases are built for structured data. You want to find user ID 1234? Boom, easy, done. But AI deals with unstructured data, like text, images, and audio. And with traditional search, you're relying on exact keyword matches. Imagine a user searches your e-commerce app for running shoes, but your product title says athletic sneakers. Well, traditional SQL search returns 0 results, and boom, you just lost a sale. But vector search? It uses semantic meaning. It mathematically understands that running shoes and athletic sneakers represent the exact same concept. It knows that feline and cat are the same thing. For user experience, that is an absolute game changer. Now that we totally get the problem, let's move into Section 2, core concepts of vector space. We're going to look at the actual mathematical building blocks of semantic search. The absolute crucial point here is understanding vector embeddings. Think of an embedding as a universal translator. It takes the meaning of unstructured data and turns it into a list of numbers. So an embedding model might score the word puppy across all these hidden categories. Maybe it gets a 0.9 for fluffiness, a 0.8 for playfulness, and a 0.1 for danger. It then outputs a vector array like 0.9, 0.8, 0.1. For a PM, this is your translation layer. But here is a critical operational fact you've got to remember. If you ever decide to change your embedding model later, you have to re-index your entire database. Why? Because the underlying language of those numbers has completely changed. And here's where it gets wild. When we turn meaning into numbers, these vectors don't just sit on a flat 2D piece of paper. They live in a high-dimensional space. OpenAI's embedding models, for example, map concepts across 1,536 dimensions. Just imagine a 3D map, but multiplied by 500. It's crazy. If 2 points are close together in this massive space, it means their meanings are similar. But as a product manager, you have a really strict trade-off to manage here. More dimensions give you incredibly nuanced accuracy for complex documents, sure, but they also bring higher query latency and significantly higher storage costs. So how does the database actually measure if two things are close in that massive 1536 dimensional space? Well, it uses similarity metrics. Cosine similarity measures the angle between vectors. This is usually your go-to for document search or article recommendations. Then there's Euclidean distance, which measures the literal straight line distance. That's often your best bet for computer vision and finding visually similar products. And finally, dot product. It's incredibly fast to calculate and used when absolute magnitude really matters, like if you're ranking search results heavily by user popularity. You don't need to do the math yourself, don't worry, but you absolutely need to know which tool fits your product's specific use case. Let's pivot from the math to the actual product application. Welcome to Section 3, Understanding the RAG Workflow. This right here is how we stop AI from just making things up. If you're managing an AI product, Retrieval Augmented Generation, or RAG, is about to be your best friend. Look, instead of asking an LLM a question and just crossing your fingers that it doesn't hallucinate some fake, highly generous company refund policy, RAG forces the AI to look at a factual reference library first. It's the ultimate solution for giving your AI secure access to your private, real-time company data, completely avoiding the massive expense of retraining the model from scratch.
Let's look at how this builds a complete, grounded answer in 5 brilliant steps. Step 1 is ingestion. You take your company's PDFs, break them into smaller chunks, embed them, and store them in the vector DB. Step 2, the user asks a query. Step 3, and this is where the absolute magic happens, is retrieval. The system turns that user's question into a vector, mathematically finds the closest chunks of information in your database, and pulls them out. Step 4 is augmentation. It combines the user's original question with those freshly retrieved facts. And finally, step 5 is generation. The LLM reads those facts and generates a perfect, completely grounded answer.
Okay, so now what's really interesting is how we actually measure the success of the system. Let's switch to the executive dashboard in Section 4, KPIs and Product Strategy. When you're out there evaluating providers like Pinecone, Milvis, or Weaviate, this framework is your holy grail. First up, latency, specifically your P99 latency. This tells you how fast the search returns. If you're building a real-time chatbot, a slow database absolutely kills the user experience. Then there's recall. This measures whether you're actually finding the most relevant results or just ones that are kind of good enough. But here is the classic PM balancing act. Pushing for higher recall often hurts your latency. Throughput dictates how many users can hit your database at the exact same time during a traffic spike without crashing the whole thing. And finally, cost per vector is critical for your ROI. This metric will absolutely drive your decision between using a managed cloud service or hosting the database yourself. Right, before you run off to build your architecture, let's cover Section 5, common pitfalls to avoid, because these are the critical mistakes that sink AI products before they even get to launch. The biggest mistake I see PMs make is treating vector search as if it's automatically smart. It isn't. It requires tuning. One massive pitfall is failing to optimize your chunking strategy, meaning how you break up your documents before you embed them. Another huge one is forgetting metadata filtering. Think about it. If a user asks, what were our Q3 revenues, and you don't filter your search strictly to the year 2024, your AI might pull a brilliant, semantically perfect answer from 2019. Metadata is what keeps your vectors grounded in reality. And finally, ignoring the power of hybrid search is just a massive missed opportunity.
Which perfectly brings us to why hybrid search is almost always the default best choice for products. Look, vector search is amazing for catching semantic vibes, concepts, and overall meaning. But what if a user searches for a highly specific SKU, like error code 404-B? Semantic search might actually struggle there because the exact string of characters is what matters, not the general vibe of an error. Hybrid search combines the magic of vector meaning with old-school exact keyword matching. You literally get the absolute best of both worlds. Okay, if you need to justify this whole architecture to your leadership team tomorrow, I want you to memorize this exact phrasing. We're using a vector database to act as a searchable brain for our AI. It allows the model to look up specific business data in milliseconds, ensuring answers are accurate, grounded in fact, and honestly, way cheaper than retraining a custom model. That right there is the value proposition of semantic memory wrapped up in one perfect sentence. I want to leave you with a final, absolutely vital question to consider for your own application. In that RAG workflow, we talked about chunking your data, right? Well, here is the ultimate PM balancing act. If your chunks are too small, you might slice a sentence in half, and the AI loses all the context. But if your chunks are too large, like embedding an entire 50-page PDF at once, the specific semantic meaning gets completely diluted and lost in all that noise. So, looking at your unique, unstructured data right now, what chunking strategy will you choose to ensure your product actually understands what your users are asking? Think about it. Thanks for joining me on this explainer, and I'll catch you next time.